All righty then. Welcome, everybody. Welcome to Delve. I am excited to have everybody here for us, both everyone online and the folks who are here in the room today for our 8th presentation of the JeffSolves MedTech program. So I'm just going to pull up a few quick slides to thank all of the great people who are involved in this program and making it happen. So first thing is, we are excited to be a part of the Design Philadelphia Festival this year. We've been giving this presentation as a part of the festival over a number of years. Even through the pandemic, we kept the program going, and it's great to have the support of the Design Philadelphia folks. For everybody online, welcome. We will be taking questions, so please submit your questions if you're online using the Q&A feature. So big thanks goes out to the JeffSolves program team. I have to mention by name the 2 collaborators that we've been working with on this program for the longest period of time, and that are the folks in the Industrial Design School here at Jefferson, Todd Corlett and Eric Schneider. Thank you so much for being awesome collaborators. And this year we have a new collaborator from East Falls campus, Becky Flax from Textile Design, joined the team along with her students. Thank you. Very good. The folks from Dell who have been really fantastic partners in helping us develop these concepts and bring in their expertise: Tom Dooley, Patrick Brandon, Jeremy Ridley, and Justin Beckstein. And then, of course, I have to thank my colleagues, Rose Ritz, Heather Rose, and then Bon, Morgan, Mary Ellen, Sarah, and Ray, everybody who makes innovation in the Health Design Lab run and makes this program really fantastic. Thank you so much for all of your work. Next, one of the fantastic things about this program is that the students who are involved in it get to spend time in Jefferson clinical sites, identifying real problems that are experienced every day by our nurses, our doctors, other clinicians, and our patients and their family. We could not do this today without the support of frontline nurses that you see here on screen. And a very special thanks goes out to Dr. Kate Fitzpatrick, who's been kind of the lead executive champion for helping us get access to the clinical environment. Now this is our 2nd or I think 3rd year working with her on that. So it's been really fantastic for our students. Congratulations. Thank you. Congratulations to our 3 teams of students who are here with us in the room today. You're going to be introduced to each of them yourselves when they come up here and present out. I'm really excited to put these out into the world, these ideas out to the world for the very first time. These students have worked so hard and put out in many hundreds or thousands of hours into the development of each of these concepts that will be shared with you today. So real quickly, I would like to introduce somebody who is here to wish everybody good luck, and that is the provost of Thomas Jefferson University, Dr. Matt Baker.
Thank you, Rob. Well, thank you for inviting me. This is my 2nd night in a row of exciting things. Design Philadelphia opened up with their grand opening last night, and so this is great. I love this event. It's an amazing event. It for a variety of reasons, but one, it just sort of speaks to the DNA of the place, which I like, all of the creativity, innovation, collaboration, transdisciplinary work. It's just a point of distinction for the university that I'm particularly proud of. And it really is, it just puts together the fact that we are educating people, we're enhancing creativity, and we're improving patients' lives. And so I think I appreciate everybody's work here. And on behalf of Dr. Susan Aldridge, who's our president, who's online, but she's actually at another Jefferson event, and the leadership team, thank you for being here. Thank you for inviting us. And thank you.
Thank you so much. I mean, we could not be doing this type of work without, these champions from our senior leadership. So it's amazing to see this all come together in the form of students getting a really great experience. Next, I just want to invite up a representative from Delve, and that is Tom Dooley.
Good afternoon, everybody. Thanks for coming out. I think this is our 5th year supporting this program. It's a great program. We're very happy to be involved, and we look forward to continued efforts in the future. And hopefully we see you guys at future events at Delph. Thanks.
Thank you, Tom. All right. So without further delay, we're going to call up our first team. And just give me a second to pull them up. It is going to be TeleComfort, and that's with Katie Yerkes and Saurav Sumughan. Oh, here you go.
Thank you so much. Welcome to our presentation on TeleComfort. We're really excited to be the first ones talking to you guys today. So to introduce myself and our TeleComfort team, my name is Katherine Yerkes. I'm a second-year medical student.
And my name's Saurav. I'm also a second-year medical student. Oh, that's the wrong presentation.
There you go.
All right. I'd like to start out by introducing you to Joseph. Joseph lives with congestive heart failure. He enjoys being in nature and values freedom in his life. But one day, Joseph has a congestive heart failure exacerbation. He's admitted to the hospital, and specifically the advanced heart failure unit. There, he's put on cardiac telemetry. Basically, what this means is Joseph's heart is monitored 24/7. And cardiac telemetry basically records ECG readings at the bedside and transmits that to the nurses station so they can keep track of him throughout his hospital stay. And Joseph isn't alone. There's tens of millions of non-ICU patients in the US being monitored with cardiac telemetry every year. Specifically in Joseph's case, he's put on mobile cardiac telemetry. This allows Joseph to stay active while he's in the advanced heart failure unit. However, although this allows for him to not have to stay in his bed his entire hospital visit, there's the issue that if a lead wire comes loose or the signal gets lost, a nurse receives an alert and their workflow is interrupted. So there's the issue of how will Joseph perform all of his daily activities while being physically connected to this mobile telemetry device. One current solution is he simply carries it with him, which can be cumbersome. There are, however, some currently available holders. And I won't go into the details right now. We'll do that in the next couple of slides, but just notice that a lot of the current models all have a similar shape. They're all this kind of thin material with the same rectangular shape. So to go through some of the issues that we see, they're often unstable. You can see in this animation, these holders allow the unit to sway while you're walking, and bumping the wires together can cause artifacts. And this will alert the nurses with false alarms, causing disruptions in their workflow. The telemetry device is also not secure in the pouch, so while patients are doing tests of everyday living, there's a chance of the device falling out of the holder as well. These holders are also uncomfortable. You can see this specific model is tied around the neck, and this weight really hangs down. The knot and narrow straps also dig into the skin, and excess straps hang down and get in the way of whatever task the patient is doing. There's also the issue of limited size and fit. There's really only one way to hold this wear this specific holder, and it takes a lot of manual dexterity and 2 hands to tie the knot behind the neck. There's limited adjustability, and this doesn't necessarily fit all body shapes. And this can also interfere with other medical devices. One other issue is there can be disruptions in sleep. Sometimes patients take the unit out of the holder for comfort while they're sleeping, and the unit can fall, like you can see in this animation. This can it leads to get displaced and cause physical discomfort to the patients. It can also cause the leads to need to be readjusted, which requires the patient to be waken up and the nurse to have to interrupt their workflow and come in, which decreases the satisfaction that both the nurses and the patients have during their stay. Another issue is these pouches aren't really universal. The current holder that we have at Jefferson Hospital was designed for the previous telemetry unit, and when they switched over, they stopped fitting. And as you can see, the hospital also likes to put in these asset trackers, which adds a bunch of bulk, which also makes it even more difficult to get the unit in. Finally, one of the main issues is it's difficult to use the current holders. As you can see in this animation, the interior of some of these pouches make it difficult to get the unit in and out of these pouches. This is really important because these units have to have their batteries changed very often. The wire adapters have to be able to be easy to be accessed, and patients can't take these units easily in and out of these pouches.
So we talked about a lot of different issues with the currently available holders on the market, but let's put some numbers to it. So we know based on current data that the average nurse spends about 20 minutes per patient per day on telemetry related tasks. And we know the national average salary for nurses is about $42 an hour. And there are currently between 80 and 270,000 non-ICU patients that are monitored using mobile telemetry each day. Putting these numbers together, we can see that if a better designed telemetry holder saves a nurse even just 5 minutes per patient per day, that has the potential to save nearly $350 million in national wage productivity each year. So in thinking about all of these issues and problems with the currently available options, we focused on what are the needs of different stakeholders. Nurses, patients, and hospital systems were our really big three stakeholders, and their focuses were on nurse workflow. What are the types of things that allow them to get through their day and their job tasks easier, like easy access to the device, an easy ability to put on and take off the patient, minimizing false alarms and disturbances, and maintaining hygiene in the hospital setting. We also wanted to focus on patient comfort, accommodating different body sizes and wearing preferences, and to incentivize hospital systems to use a better holder, focus on things that'll really protect their assets and protect the device security, as well as limit cost. So introducing the TeleComfort, this is our prototype for a better holder that patients can wear while they're using mobile telemetry. One of the big solutions we have, first and foremost, is that it's easier to don and doff, both for patients to do themselves and for nurses to do for patients. It can be looped around the torso or placed over the head and shoulder. The long strap loops back on itself so that there's no dangling bits. And there's an additional anti-sway strap that can be clipped to the clothing directly to prevent unwanted movement. This solution also has a more adjustable fit. It can accommodate petite and large body habitus. It can be wearable both high up on the chest or low down on the hip, depending on what's most comfortable for the patient. It can be worn across the body or around the waist, which can allow for accommodation of other medical devices, such as central lines or insulin pumps. And there's no excess dangling straps or ties to get in the way of anything. It's also very secure. This innovative conical shape holds devices that are different sizes in such a way that they can't fall out, but that they still have openings to allow for easy access to the key components like the lead wires and the battery housing. They can also fit different brands and shapes and styles of telemetry devices. The flap top can be closed at different heights, whether the device is tall or short. There's internal modifications that can better accommodate narrow devices. And even when the patient is wearing the holder, nurses can easily access the battery change compartment, which is important because the batteries need to be swapped out about every 24 hours. We also devised a solution for patients who may be lying in bed or sleeping and don't want to be wearing a holder strapped to themselves, but still need to be connected to their mobile telemetry unit. The anti-sway strap can be repurposed as a tether and loop that can be looped around the horizontal rail and clipped to itself. And this allows the unit to be accessible, remain upright and near the patient to minimize falling. So when this obviously wasn't our initial design, and we went through a prototyping process that was iterative, where we would think about the different solutions we might try, test them in the real world, get feedback. And this really helped us decide what are the features we really need and what are the features that we really explicitly don't want or maybe aren't as important as we would have otherwise thought. And the feedback we got from nurses and patients in the hospital was that this is much better than the other style, and it really does improve their workflow in a meaningful way. For materials and construction, we are focusing on using non-woven spun-bound textiles and seaming with sewing construction because it's the most sturdy possible way to seam in medical textiles. And we found that when we spec'd out the cost of producing, it's actually going to be less expensive than all of the currently available options, which will be important for getting hospital systems to adopt this holder. In terms of the market outlook, mobile telemetry is only going to continue to grow, and hospitals are the largest purchasing group. And looking forward with the TeleComfort, we are going to be continuing testing in the hospital, getting feedback, and investigating our IP potential, and hopefully eventually getting it to market so that patients and hospitals can really use it. Thank you so much to the JeffSolves team and the Jefferson University Hospital and Dell for all of your help this summer in innovating.
All right, so I'm just going to stop our share. And again, for the folks in the audience, we have a 5-minute Q&A period after each team presents. I think you're going to see, just like this team today, there's a lot of really great examples of relatively straightforward, simple design solutions, which make a big deal for people on the ground, right? I think that is something to keep in mind, right? With all of these ideas, people talk a lot today about the challenges that people in the healthcare workforce face. Well, oftentimes the challenges they face is many, many small little things like this, right? Many small, death by 1,000 cuts, if you will. So I love these concepts that are unveiling kind of these needs that people see, but people who work there every day see, right? But we and others don't necessarily understand until you really dive in. So with that being said, any questions in the audience? And if you want to just go ahead and say it, I'll repeat it on the mic for those in the virtual audience. Go ahead.
Are making products such as these that you might consider partnering with from a manufacturer?
So the question was, who are some of the companies that you might be considered partnering with for manufacturing this device?
So there are companies that just do large, different kinds of medical textiles, things like Meditech, where they're creating a lot of different non-woven medical materials for the healthcare space. We think that's one way to look. Another place to look is the companies that make these mobile telemetry devices. Not all of them make holders for them. And I think it'd be a really helpful partner to have someone like GE who makes this specific shape and model to come to them and say, hey, we have something that could fit yours. And this could be a way that you could have continued purchasing through these hospital systems that you're already partnering with for your equipment and your other reusable things like batteries and other non-durable medical equipment.
Back there?
I am a baby here and
so the question was, they understand that the construction costs and materials are cheaper than the currently available models, but will the waste costs be any different? And our expectation is no, because the reason we're going with a disposable material is based on all the feedback we have about how often these things get soiled and how difficult it would be to clean and maintain in the hospital setting. And so we expect that the day-to-day usage would actually be increased with this because ours is a little bit durable. And so theoretically, they would have to buy fewer of them, but at most, it would be replaced at the current rate. Thank you. That's a great question. That was actually a big part of... Sorry, the question was in the examples we gave of the existing holders, a lot of them had see-through pouches, and is that an important functional feature? And when we were going through the iterative process, that was a big question we had, and we would go back and forth over whether the telemetry device itself needs to be seen while it's in the holder. And the feedback we got from all nurses is no, more often than not, you don't need to see it. all you need to be able to do is, if there is something you need to see it for or change the batteries, get access to it quicker. And so the fact that our design doesn't show it, but makes it easier to take in and out, actually improves the functionality over something that is harder to take in and out of where you can see it.
All right, another round of applause. Thank you very much. Okay, the next team up is Team SoloGo. Team SoloGo, if you want to head on up. Okay. Just give me 1 second to share. All right, and you're up. Yep, clicker works.
Hello there, everyone. Thank you so much for being here today. My name is Tyler, and our product is SoloGo, reaching new heights in the bathroom. To begin with, I wanted to introduce you to our team. Once again, my name is Tyler. I'm a second-year medical student here at Jefferson.
My name's Steven, and I'm also a second-year medical student.
And my name is Cariah. I am a senior industrial design student.
So what's the problem? Well, meet Sam. Sam just gave birth to a beautiful baby boy, Milo, by a C-section. But due to Sam's incision, she struggles to lean forward when using the bathroom in the cramped, crowded hospital restrooms. Now Sam needs to call a nurse or patient care technician to come in and assist handing her toilet paper. And as you can probably imagine, she feels embarrassed and helpless. But is Sam's experience unique? Well, unfortunately not. Up to 80% of patients struggle just to reach the toilet paper at some point during their stay in the hospital. And this can be from a variety of reasons, like varying body sizes, neurological issues, even post-surgical patients all may struggle to reach the toilet paper at some point during their stay. This inevitably leads to patients waiting up to 20 minutes for a tech or patient care technician to come and assist them. And while each one of these interactions may seem relatively innocuous, this can happen up to 50 times per day per floor of the hospital. But what's important to remember is after we surveyed a number of techs and nurses, they all pretty much unanimously said that patients do not actually struggle to wipe themselves, and the real issue with accessing the toilet paper is strictly because of the dispenser. So what are the consequences of this problem? Well, as you can probably imagine, there's reduced autonomy and reduced privacy, and this can reduce patient satisfaction. I mean, how would you like it if someone had to constantly come in and hand you toilet paper? But in a more real sense, there's a risk of injury. A lot of the times these toilet paper dispensers are in shapes that make it really hard for patients to access, and they may risk even falling off the toilet seat. And then on the more institutional side, you have to deal with the staff constantly being interrupted throughout their day to go and assist patients, just handing them toilet paper.
So you guys might be wondering, how much can this really cost a hospital system? And we were wondering that too. But before I give you the answer, I want everyone to ask themselves, how much does it cost to hand people toilet paper? So our team decided to come up with an estimate. We know based on how many patients that Jefferson sees a year and how long they stay, how many nurses will be on staff at any given time. And then, based on our survey of the nurses, we know how many times they're helping the patients reach the toilet paper, the same for techs. Now that we know how many times that they're helping the patients per day, we can figure out how much time that they're spending every trip. Combining these along with the average daily salary or hourly salary of a nurse or a tech, we can figure out how much money is wasted just handing patients toilet paper. So I want everyone to have their number in mind, and our estimate for how much money is wasted on toilet paper is $2 to $6 million per year just at Jefferson. And what's even crazier is if we were to scale this up to the entirety of the United States, this costs the US healthcare system $200 million per year just handing patients toilet paper.
So what does this problem look like? Oh, so sorry. Oh. All right.
Toilet paper designs are often quite bulky.
Excuse me. So sorry about this. Well, as the video said, current toilet paper designs are quite bulky. And because of this bulkiness, patients actually struggle to fit their hand underneath the toilet to reach the toilet paper. Now, if a patient needs to use their opposite arm, this also may be difficult. And this is a problem for a large number of patients. Now, if a patient does manage to grab the toilet paper, they may have to rip it at strange and odd arm angles. So what's the key to this problem? Well, the issue is that the toilet paper is located in an inconvenient place where it competes for space with the grab bar. And as a result, it is hard to access for most patients. And as you can see here, this is just one example of in the Silvestri wing of Washington Township Hospital. I mean, I'm basically using that toilet paper dispenser as an armrest at this point. How it's quite, and it would be quite difficult for me to reach the toilet paper myself. So what does this problem look like? Well, it's not just a problem at a hospital. On Jefferson campus in Hamilton Hall, at Panda Express down the road, in the Fashion District Mall, and in Starbucks, all of these places possess toilet paper dispensers that have some limitation for one or a number of different patients and a number of different mobilities. So we said, how might we design a toilet paper dispenser that allows for ease of access to toilet paper, given the restraints of limited patient mobility and variations in body type? So Cariah, what design considerations did we have?
Thank you. So based on the feedback from nurses and patients, we have compiled 5 integral design considerations. The first, the dispenser must be adjustable for varying body types. 2, the design must be compact and lightweight. 3, ADA rules must be taken into consideration, as well as the design must be easy to clean. So with that in mind, this is SoloGo. So alongside, I'm sorry, one sec. So with these design considerations in mind, we created SoloGo, the first adaptable toilet paper dispenser of its kind, fully designed with a user toileting experience in mind. So now that how did we get here and what was the design process like? Alongside our extensive research, we first explored toilet paper placement, such as hanging it from the grab bar, attaching it to the toilet seat, or even hanging it from the ceiling. Secondly, we explored the possibility of integrating the grab bar and the dispenser. However, while this was an interesting thought, we quickly found that it decreases the functionality of the grab bar itself. Hence, the notion of having the dispenser hang from the grab bar was the best option. Further along our journey, we then started looking at the dispensing mechanisms and features. This exploration introduced key features like dispensing the toilet paper from a side opening, rotation, and sliding the dispenser along the grab bar. Now, with all these discoveries in mind, we began prototyping. For concept 1 and 2, the side opening was slanted and placed at an angle, which we hoped would have increased patients' ability to access the toilet paper. However, testing this design feature, we found that the slanted opening did not add a significant amount of aid to the patients. Further along in concept 3, the slanted opening was removed and we began to increase the surface area of the clip for a more lumbar support. And in our 4th concept, we then gave the device the ability to rotate, which would help patients who can only use the opposite hand to access the toilet paper. Another important feature we added to concept 4 was the implementation of a removable cartridge, which allowed for easier cleaning. So throughout the design process of SoloGo, we recognize that nurses and patients are not the only individuals that would be interacting with the dispenser. Thus, we took our prototypes to our other stakeholders, the first being environmental services, and they approved the removable cartridge for easier cleaning, and it also lessens room turnover. They also emphasize the need for the toilet paper dispenser to be secured and locked to prevent theft. The other stakeholder was the occupational therapist. Their expertise of the human body, they approved the placement of the dispenser as well as the adjustable features that aid patients with varying body types and conditions. They also voiced their concerns with the possibility of the dispenser sliding unintentionally if someone was was to place their weight on the dispenser. So with that said, we went into redesigning the clip so that it would allow the tensioning of the grab bar to not slide on intentionally. So like other dispensers, we have the post inside of SoloGo that holds the toilet paper. We have a cutting edge and a lock for security. However, SoloGo has two unique parts that makes us different from other dispensers. The first being the flex clip, which stretches and snaps onto the grab bar through the use of tensioning that allows it to lock into place. And that allows it to lock into place. And in the event that there was the need to adjust the grab bar, you can easily slide it along the grab bar. Secondly, there's a hidden release mechanism located at the top inside of the carriage. This release mechanism consists of a spring-loaded L plate, which is supported by the track brackets, and environmental services would place the tips of their fingers into the cartridge to pull the spring-loaded plate, which releases the cartridge from the clip. So how does this work? Let's see it in action.
Oh, so sorry. Bear with us for one more video. We apologize. Yeah. Oh, it's not showing? All right. Yeah.
Let me change the book. Oh, I see what's going on. I can fix that. One moment. Share and share. Which one? That one. There you go. And go for it.
SoloGo installs in a matter of seconds onto any ADA compliant grab bar. If a patient finds that SoloGo is too close, they can slide it away from themselves. And if the patient finds that SoloGo is, too close, they can slide it away. And too far, they can slide it closer to themselves. If the patient needs to use their opposite hand, they simply turn SoloGo 90 degrees and pull like normal. If a nurse does need to assist a patient, they can simply slide SoloGo out from the wall, turn the cartridge, and continue to help the patient. So toilet paper does need to be replaced, so environmental services simply detaches the removable cartridge and replaces it with a new one.
So close to being able to actually get that thing on the screen.
Just keep going. We're all done.
You have a physical one, so
yeah.
You can show the people in the room the real deal. It's a real deal. And
that one.
Go for it.
It's not okay. So the one thing we have to, what is it? We have to.
Okay.
So Stephen, how does SoloGo compare to the competition?
Well, we decided to compile all the toilet paper dispensers we saw in other commercial and public spaces where people are using the bathroom. And as you can see, SoloGo manages to address a huge variety of mobility concerns that people regularly face. Now, you might also ask, well, with all these added features, how expensive is it going to be? Based on our estimates from experts at Dell, thank you very much, we found that SoloGo can maintain a competitive price point with the other currently available dispensers. Next, you may be asking, where are we going to implement it? We first wanted to start out in healthcare spaces. So as you can see, there are hospital beds and nursing home and rehab center beds, hospice patients, assisted living center beds, and ambulatory center patients. And if you put them all together, there's a total of 6 million healthcare toilets in total that we can equip with SoloGo. But our team also is wondering, does this have applications outside the healthcare space? There's a lot of there are many spaces where they need to be brought up to ADA compliance. And when they do, SoloGo is consideration for them because of the grab bar. So these buildings include schools, lodgings, offices, public bathrooms, restaurants, and retail. And if we add them all together, there are 15 million buildings in total that we can equip with SoloGo. And mind you, that many of them will have multiple bathrooms in them.
So in closing, through our journey, we have witnessed how much innovation can take place in the forgotten spaces. And SoloGo is the next step in reinventing patient autonomy in the bathroom. Thank you, and we invite any questions you may have.
Room for like one question, and while you're at it, why don't you show everybody in the room who didn't see your video the actual prototype that's hanging right there that works.
And so like we said, SoloGo slides on any ADA compliant grab bar and is able to turn 90 degrees for easy access with the other arm. In the event that environmental services needs to replace it, it simply detaches from its clip. Is replaced, the toilet paper is then replaced inside the cartridge. It's cleaned thoroughly, and then you put SoloGo right back on the clip. In theory, you do that with two hands. So,
all right, thank you. All right, do we have a question in the room or in the virtual audience? Nothing in the virtual audience. Go ahead, Heather.
When I see hospital bathrooms, they usually have those really large toilet paper rolls to save money, I think, with that maybe not with cores. Did environmental services or procurement talk to you about using those to save money and whether or not that would be an issue with your dispenser?
So the question was, do hospitals use the very large industrial size rolls versus this device, which looks like it uses smaller rolls?
So in essence, in a lot of the more public bathrooms in a hospital, you're going to get those large rolls. But most of the time, and this product's primarily designed for that kind of single patient room or something like that, you're going to be dealing with these smaller rolls, and that seems to be the case in most hospital systems. This is designed for the coreless style of smaller roll, but we found that that's primarily the thing that environmental services is going to be replacing throughout their time interacting with patients and in those kind of more specific patient restrooms.
All right, thank you. We're going to have to move on to the next team. Okay. So we have, got to say it, last but not least, we have team lineup. Do you guys have any videos I should be notified? No, just kidding. All right, go ahead.
Okay, thank you. Hello, everyone. Oh, thank you sorry. Thank you so much for being here at our JeffSolves presentation for our product, the lineup. My name is Ava Milani, and I'm a second-year medical student at SKMC.
I'm Yasmine Eichbaum. I'm also a second-year medical student.
My name is Tiffany. I'm a PhD candidate in textile engineering.
My name's Calvin. I'm a senior industrial design student.
And my name's Matthew. I'm a second-year graduate student in industrial design.
This will be our format for today. So I want you to picture yourself as an ICU nurse. You're fully immersed in your 8th hour of a demanding shift. Just as you finally start to catch your breath, a new patient arrives from the operating room, and they're assigned to you. The patient's attached to 3 peripheral IVs, a central line, an arterial line, a Foley, and multiple drips that are all intertwined without any clear labels. As frustrating as this isn't something you encounter just once in a while. It's a routine part of your day. But the impact of this tangled web reaches far beyond this frustration. Every minute you spend untangling wires is a minute you could be spending improving your patients' lives and care. And while managing this complicated mess, your likelihood of administering inaccurate medications increases. This is the problem that we're trying to solve.
So as Ava was just saying, we had the chance to shadow one of the ICU floors at Jefferson. And as you can see, there's a very complicated setup. You have IV pumps, a bunch of lines. Here is an example of an IV line attaching a patient across the body. And then here's some other examples of IV lines attaching at different parts of a patient. And if it's really hard to decipher what's going on, that's the point. It's really difficult to keep track of what's going on. And so one of the other issues that happens is that all these lines get tangled. And that's one of the areas that we wanted to focus on for our project is how do we avoid tangling, the tangle of the lines. And we had the chance to talk to nurses about the main issues that come up. And there are many, but one of the most important ones that they describe is that it makes it really difficult to trace the line back up to the appropriate medication, which is where, a lot of serious consequences can occur.
So this problem that we've just been describing for the last few slides is actually something that's been well published in scientific literature. When IV lines and cords become so tangled that they look like a literal bowl of spaghetti, it's called spaghetti syndrome. This creates a lot of errors, most often during IV line setup. Sometimes these errors are very serious. Medications can be added to incorrect lines, can be added to lines that aren't even attached to a patient. It's resulted in patient deaths, permanent injuries, and serious life-threatening situations. And unfortunately, there are no conclusive interventions available right now.
As Ava mentioned, tangled IV lines can prevent patient care. So we talked to a couple nurses after shadowing them, and we found that each nurse takes about 3 to 5 minutes per hour to untangle IV lines. When a nurse has 2 patients, that means a nurse can take up to 2 hours per 12-hour shift untangling IV lines. So in a unit, if a unit has 7 nurses and each nurse takes up to 2 hours to untangle IV lines, that means one hospital unit will spend up to $459,000 a year untangling IV lines.
So not only is this an expensive problem, nurses are very frustrated. They've created many workarounds on their own, and they're all aimed at shortening the line. They will wrap excess line around the pump on the IV pole. They will just tape up the excess line with their own tape, or they'll use a tongue depressor and slide the line under it that's been taped under the side of the bed. But these all bring their own problems like infection risk and increasing your risk of getting the line pulled out of your arm, which is painful and frustrating for the nurse and patient.
So after interviewing nurses, we found that excess IV line length and subsequent tangles are one of the biggest slowdowns in a nurse's shift. So we developed the following problem statement. How might we help inpatient nurses caring for patients with multiple IVs modify the length of IV lines to help with the line organization and improve efficiency? Approximately, there are 150 to 200 million peripheral IV catheters placed each year.
With a market size this large, you would expect to have a lot of different products that are being used, but really there aren't that many. We've scoured the internet for them, and we have found that none are really widely used in hospitals. Here are a few, but after our extensive research and many, many conversations with ICU nurses and nurses from different floors of the hospital, we found that they need a product that will reduce the length of the line. It's disposable, it's easily adaptable to different situations, it's intuitive for them to use and for other new nurses to use, and it avoids the adhesion.
So in assessing our problem statement, we came up with the following design criteria. We wanted our device to reduce the length of IV line. We wanted it to offer rapid release of any wrapped up IV cable or line. We wanted it to elevate IV line off the floor. We wanted it to be intuitive to use, and we wanted it to be adjustable for a variety of different rooms or use case scenarios.
So how do we get to this end product? We started the summer with our prototyping process that began with the blue and the 2 gray items to the left. These were part of a concept that we call the loop concept, which is kind of like a shoelace concept where you can pull both sides and that'll shorten or lengthen the line. The nurses really liked this because it was quick and easy to use. The problem was that it created some disorganization in terms of a visual sense. So if a nurse came into the room with this, it would look more disorganized. As you can see here, from the prototypes to the right that came later on, we gave them to some nurses, and after some use, this is what they came up with. So they didn't use it in the way that we intended them to use it. So we went back to the drawing board and thought, well, how can we do something that incorporates the process that they wanted to do in the first place? This led to a transition to what we called our wrapping prototypes. Our wrapping prototypes consisted of the nurse wrapping the IV line around a cylindrical object. We just had to answer a couple questions. Where would this object be stored? It's a cylindrical object, so that takes up a lot of space. And will it just free flow on the line, or could it hang somewhere? The nurse really wanted a stated location in the room for this object to live. This then led us to what we called our flat surface hanging prototypes. Obviously, we had to do some sizing changes in terms of how much you could wrap the line around, and then ended up being a focus where it had a hook and a body. The hook would be able to hook from different locations, primarily the bedside next to the patient, and then the body was what the nurse would wrap the line around. The body consists of a bunch of notches that the nurse can place the IV line inside of and then wrap around, creating a stability feature. So this is our current design. It consists of a hook with a 1.5-inch diameter that fits the majority of bedsides and bed rails. It can also hook from different places, such as the IV pool, the patient gown, etc., wherever the nurse may please. The hook folds up and then can fold horizontally, so if it lays flat against the bedside, it doesn't protrude out. The body of the hook, as you can see, has a large hole in it. This is for sustainability purposes and manufacturing purposes, so that we take out a lot of material. And then you can see the notches. There's 3 notches, not 4 as the previous models. The 3 notches are on the way so that the nurse knows where to start. So the nurse starts top left, begins wrapping, and then ends bottom right. This also has a feature that we call the quick release feature, which was really important to the nurses. The nurses wanted something that if a patient pulls, this releases instead of yanking the IV line out. So as you can see in the video to the right, if a patient would pull on one end, or if a nurse pulls on one end, the object releases to the full length of the IV line. That would be standard.
So now you can see that our product, the lineup, satisfies all of these characteristics that we were looking for, and nurses are satisfied with it so far. Yasmine is going to do a demonstration of how it works.
Yeah, sorry. Thanks, Ava. So here you have the IV line. I don't know how much everyone around can see, but as I'm tangling it, you'd start at the bottom, which is actually where would be connected to the patient. And you can see that there are these like Y sites. So you'd find the second to last Y site here. And this will be attached. And then you can take lineup and attach it to the first notch, and then wrap around. Sorry, I kind of like knotted it in here, but essentially you'd wrap it around and then hook it in here. So it should wrap very nicely. I'm like, sorry. There you go. And then here you can either hang it onto like an IV pole, or you can hang it this side of it then, like that. Thanks.
So there are a number of next steps that we'd like to look at going forward. We'd like to create a packaging prototype so that these are convenient for hospitals to use in large numbers. We'd also like to further refine our current prototype. It's optimized for 3D printing, but we'd like to optimize it for injection molding. We'd also like to complete an IRB study that includes both a focus group and a field study, and as well as develop our intellectual property. And just want to say a special thanks to everyone involved.
Yeah, we wanted to thank especially the nurses that we worked with, Angel, Kristen, Val, Alyssa, and Kristen Gilmore, as well as all of our mentors at JeffSolves and at Delve. Thank you.
Time for questions. We've got a few minutes. Anybody online who wants to ask anything? Been pretty quiet online. Well, it's okay. Right here in the room. Sure, go ahead. Okay, so the question is about the color of the device and what information or that could communicate, and if you've considered that.
So yeah, the color has been, when we brought our designs to nurses, whenever there was a different color, they were very excited because they immediately thought like, oh, this will be great for organizing different meds. Like if this is saline, will be one color, antibiotics, but we haven't created an organization for it yet, just because we need to look into it a little bit more, because there are some studies that show when you incorporate too many different colors and too many different organization tips for nurses, it can actually end up not being beneficial anymore. So we're going to look into it, but we definitely like having bright colors that stand out. And it also avoids the device from being lost, because some of the smaller designs that are already on market, a nurse complaint was that they would get lost in the bed or just lost in the hustle and bustle of the hospital.
Any other questions?
You spoke about if you had to address any condition more, you can address
He asked if we could talk about any included risks of the IV line. If anyone, so we tested the IV line with going through the pump and the different like formations of where how it would bend, if that would obstruct the fluid from moving through. And so far it's been good. They tried at different rates and all rates have been fine with the fluid. But that's definitely a concern when we had different loop designs because of the kinking. But with this design, when it's flushed against the product, it can flow through great.
Yeah, so each of the notches is actually designed a little bit instead of just a straight notch. So it's a straight notch, so it's not the soft code line.
Okay, so thank you everyone for being here today. Congratulations to the three teams for all of their work and for presenting today. If you have any questions, we're going to be here for a little while for the folks in the room. For the folks online, you'll be able to find a recording of this presentation on our website at healthdesignlab.com not long after this event is over. Thank you again to everybody for joining us today, and we look forward to being back next year. All right, bye-bye.